right. Good afternoon, ladies and gentlemen. Long time no see. I know it's been a little while since I've done a stream. So I've gotten into the habit of doing these streams every Friday, as you might know, but you might be wondering, well, you weren't here last Friday. Where were you at? Well, I was here at my house, but I was busy getting this guy here. So this is the Nintendo Switch OLED. I am a big Nintendo fan, and so not only did this come out, but also the game Metroid Dread came out. And so I decided to take last week off to play that game. So I already did finish. I finished Metroid Dread I think 2 nights ago, and it was a lot of fun. But anyway, that's not what you came here for, and we got a packed stream today. Lots of stuff to cover. It's been a while since we've touched this project. The last couple streams, we've done a couple of other random things. You might have seen the other day that I was going to do another stream for Titanic around Docker Compose, and then I decided to scrap it just because. Well, before I don't want to get into that quite yet because I want to give a recap for anybody that's new on what we've done so far. So what we've done so far with this Titanic series is we are basically taking the starter Titanic set. Oh, I always got to do this backwards because I got to remember the camera. From start to finish, from like taking the raw data, doing all the feature engineering, building a model, packaging it as an API, and then deploying it. And so we've already done a couple of these steps already. We got the data from Kaggle, the raw data set, and then we did a stream a couple weeks ago on all the feature engineering. Then we did another stream on building this pipeline to actually package the model as a serialized pickle file. Then we, in one of the last Titanic stream that we did, it was actually I think it was 2 streams ago that we actually packages this all up as a fast API variant. And then the last stream that we did was actually taking this and putting it within a Docker container. And as you might recall from that last stream, if you were there, oh, by the way, all previous streams, including this stream, are like archived, I guess, on YouTube, which means you can always watch them whenever you want. So never feel free like you have to join these live. Although I will say, if you do join live, I do have the chat window open down below, or wherever it is on your screen somewhere, but I am monitoring it down below here. So if you have any questions, please feel free to ask, and I will ask them or answer them in as quickly as I can. So yeah, let me. So about the Docker stream last time, I struggled big time to get it working, and and that's kind of the reason like it's taken so long to get back to this Titanic stream is that like it took a lot of debugging. And actually, so let me go ahead and show my screen here because I'll go ahead and show you that like what we did or what I ended up having to do, and I'll explain why I ended up having to do it. Okay, so IntelliJ, where are you at? All right, so IntelliJ is my ID of choice. I was trying to open up on my secondary screen here, so I'll give it a second here, folks. Okay, so we're loading up the Titanic BYOC project. Oh, so one other thing you might recall. So whenever we started off this project, I had originally started it as this idea of, we'll take this Titanic model all the way through to deploy out in production with just say AWS SageMaker. I decided to widen the scope of this project to include a couple other things. So, by the way, like I was starting to write, I'm starting to write a very robust README, and like that way, if anybody wants to follow along without watching these streams, they can. And so, obviously, I got to do some silly stuff in here, like this GIF over here. And I don't know why this is not scrolling. This is kind of okay. So this is kind of concerning. I don't know if you're seeing this, folks, but like I got a weird latency over here. But anyway, so I've decided to expand the scope beyond SageMaker into deploying out to multiple platforms. And that's what we're going to be talking about today with Kubernetes. So first, what I wanted to show you the Docker file. So this is my Docker file here. Just a quick recap on what we did last time with the Docker file. So this Docker file is designed specifically to work with AWS SageMaker. However, somebody, I believe it was Oskin in a previous stream, asked, can this container be used for other platforms? And the answer is yes. And in fact, we're going to use this container as is for our Kubernetes deployment. So what I ended up having to do is, because I think what I got hung up on was I didn't install these 2 things. And so whenever I kept trying to run like the Okay, well, I'm getting ahead of myself again. Sorry. So let's talk about the structure of what the Docker file does again, just as a quick refresher. So Docker file always starts with some sort of base image. You can start with your own clean, basically a clean slate. Most people never do that. They start with some sort of base image that works well for them. In my case, I'm using the Python 3.9 Slimbuster. And then you have to install your specific dependencies. So here I noted that we have to install our Python libraries that we are going to use for this project. So you can see if I go into dependencies over here and I look at the requirements.txt file, these are the various little things that we are going to be installing onto the Docker container. Okay, so, and then there were a couple of environment variables that we had to set for AWS SageMaker, and this is fine. I'm noting this as required for SageMaker, although I was starting to look into this a little bit more because I didn't know what this was doing per se. And it sounds like it's like a desired thing for really any deployment that you want to do. I honestly don't remember what this is. So we have to expose the port, and then we copy our files over appropriately. So you can see that SageMaker tends to want things in this opt program directory. So I'm moving the container files. So our fast API over here, and the other files over into there. And then I am also doing the copy of the models into this opt/models. And the reason for that is, the reason I'm not putting them in the same directory is you can see that whenever we look at our API file here, we are loading it from up one and then over, and that basically matching the same directory over here. So if I were to run this locally, we'd be running from this container directory which means we'd have to go up one to our base directory and then down into models, and then you can see off on our left we got our pickle files over here. Okay, so the challenge that I ran into actually what ended up being with probably just a challenge just for me only, and that was because as I've mentioned before in multiple streams, I have a newer Mac Mini. This is one of the ones that is using the M1 chip, which is Apple's new custom silicon chip. It is a great laptop, or no, I always say laptop because I'm so not used to having like a desktop computer. But anyway, so the architecture of these chips is just a little bit different, and different enough that it is causing some issues with some people. I think it'll get resolved in time. But quick note on that: if any major company out there is thinking, should I buy these M1 computers for my data scientists or machine learning engineers, I think I might recommend holding off another year. I mean, they've come. I think the M1 chip has been out for about a year now, and they've come a long way. But there's still kind of a ways to go. So with that, I had to do these Linux dependencies here. So what apt-get? I can't remember what. I always forget what apt stands for. It's like something package something. Apt-get. So I had to do an update, and then I had to install these little libraries, and that fixed my problem. Again, so. You might have all been following along in the stream before and had it run just fine. That was probably because you didn't have an M1 computer like I do. But now this works. And just to show you that it works, let me go ahead and do, let's go ahead and build the container again. cd. All right, so docker build, Titanic BYOC. It should just, okay, I don't know why it's building from scratch, but that's okay. All right, so I'm gonna split this, and then when this is done building, and let me go ahead and move my face out of the way for you all. Top right. Okay, so it'll take a minute or so to build, but what it was getting hung up on is this. Okay, this stats model thing here that it's showing. It kept getting hung up on this, and I don't know what it was about this GCC or libxml XML2, but it fixed it. Yeah. So one other note while this is kind of building. One thing that I do want to get to in the future is proper unit testing. Well, that's what I should have done. I'm going out of order. I really should have done unit testing. Well, no, we did a stream on unit testing, didn't we? No, I want to do more on security scans and stuff. And I wrote a whole blog post about it. It's out there on Toward Data Science. But basically, I think so. I've got some colleagues at State Farm being the company that I work for, that have found. When using, so behind the scenes, Docker does use a tool called Snyk, SNYK, to do image scanning for security purposes. And we found that there were a lot of security vulnerabilities associated to like this Python 3.9 Slimbuster image. So I'll have to, I don't, maybe in a later stream we'll figure out like how to like to properly mitigate that. But for now this works. And honestly, I'm not sure that those security vulnerabilities that were surfaced were really that like big of a deal. And in any case, we're gonna tear down all of our stuff anyway at the end of the day, so you don't have to worry about that anyway. So yeah, the Slimbuster will work. As you note here, like it takes like 3 or 4 minutes for this image to build. but once it's done, it should work just fine. And hopefully we'll see that work just fine here in a minute. What do I want to do? Oh, so let's talk a little bit about what Docker Compose was and why I didn't do that stream. Okay, so I ended up not doing that stream for two reasons. Number one, I had a really bad headache that day, and I was just like not feeling it. But the other reason is so what Docker Compose is it's a tool to basically like have an orchestration between multiple Docker containers running at the same time on the same environment. And so it's nice, but it's extremely limited. Like it's not a very good container orchestration thing. And I personally have never used Docker Compose for any real thing. And so it's not really worth showing you just to make you aware that it does exist, though. And a lot of people do use it. Instead, and that's why we pivoted today to use Kubernetes. That's what Kubernetes is really designed for. So in case you're not familiar with what Kubernetes is, let's talk about it at a high level. So Kubernetes is basically a Docker container orchestration platform. That's it at its basics. Like I know it's way more complex than that. It's really nice. I think it was originally designed by Google. This is going to take forever to run, so let me just change back to my video for a minute. It was designed by Google originally. I think they still have a strong hand in it, but I think it's mostly open source at this point. But it does a lot of really nice things that Docker Compose kind of wants to do, but like it takes it to the next level. A couple of things, like one thing to note is like, let's say, well, the really nice thing about Kubernetes is that you can have like, so basically you start up a Kubernetes cluster on a machine or a set of machines. And then whenever you want to deploy out your Docker containers and you want to have them crosstalk with one another, not only can you like have services that do proper connection with one another, but you also get to specify like how much of each resource that needs under the hood. So like, let's say you are instantiating the Kubernetes cluster on a machine that's got like, I don't know, 100 CPUs and like, I don't know, 1,000 gigabytes of RAM. Then whenever you want to start up your Docker container with Kubernetes, then you could tell it that, okay, I want only just 1 gigabyte of RAM and then like just a little bit of CPU. So that's really nice. It's very good for resource sharing. It's very good for, you can also do things, well, actually, let's go ahead and diagram this out because let me show my screen again. I can't believe it's still taking this long to run. I don't remember it taking this long to run. But anyway, all right, so I'm going to go to Safari. I'm going to use a diagramming tool. So I think I've shared before in past streams that I like to use a professional graphic design tool called Affinity Designer. When it comes to actually diagramming things for like architecture and stuff, I personally prefer to use this tool called Draw.io. So we're going to go to Draw.io. This is a free software. So first thing we'll do here, and you'll see why I like this really quickly. I don't think I showed this in a previous stream, so apologies if I'm doing a repeat here. All right, so let's create a new diagram. I'm going to call this Kubernetes architecture. Okay. All right, so the reason I really like this Draw.io here is, one, is free. But number two is it's got a lot of really nice like architectural shapes for you to use. So specifically, like we're not doing AWS today, but let's say I did want to do AWS. Look at all these nice little icons. So if I wanted to, I don't know. So let's just go ahead and open this up. I actually don't use this little interface here. I use the search shapes up here. So let's say I wanted to do something with SageMaker. I'll just type in SageMaker, and then you can see that it comes up with a number of different little icons that I can drag onto here, and then I can caption them. Hello. I don't know if you can hear the stomping going upstairs, but so I'm in my basement office and my daughters are upstairs running around. So I apologize if you can hear that. But then you can do connections and stuff like this. So very nice free little diagramming tool. Yeah. So I can't speak highly enough of this little tool. So yeah, let's talk about a Kubernetes cluster. So let's say, I didn't mean to do that. Let's call this box our Kubernetes cluster here. Oh my gosh, my daughters are really running around that thing. Okay, so let's do an empty fill. And just to make you aware of, I'm pretty sure it's in here. So if I just do a search for Kubernetes, no, I just want to. Okay, yeah, this here. This is the general icon used for Kubernetes. Like, so if you think of like McDonald's with their classic arches, or Nike with the swoosh, this is the Kubernetes logo. Okay, so let's call this Kubernetes. I can't remember. So there is a reason. So I think this is a 9-point shape. I don't know. I can't remember what you call a 9-point shape. You lose me at octagon. Or maybe it's not 9-point. Maybe it's 7-point or 8. I don't know. But anyway, the points represent something. And Kubernetes also is, I think, a Greek term. I don't remember, honestly, so I apologize for that. You could Google it. You don't need to know that, but it's just fun facts. Okay, so this is our Kubernetes cluster. So the way that Kubernetes works is in things called pods, typically. So a pod is basically our small running unit of something that we want that's going to be using some sort of compute power. So in our specific case, we will house our fast API as a pod. So actually, this is something that I'm even confused about. So let me caveat this by saying, of all the technologies we're going to be working with as far to deploy out to, Kubernetes is probably the one I know the least about. Well, actually, I take that back. I do want to do one on Google Cloud Platform, and I really don't know much about Google Cloud Platform, but Kubernetes I don't know a ton about. But anyway, oh my gosh, girls. They're sweet. I love them, but they can be, they're sweet. Okay, but they keep distracting me. So, okay, Kubernetes. So I was mentioning pods. Oh, okay. So we actually tend to deploy things out as deployments, and the reason for that is that Kubernetes kind of recommends it for production usage. But the one thing, nice thing I can say about deployments is deployment is basically like you can define like, okay, I want this specification to be for one specific pod, but I can do multiple replicas. So like, well, maybe this is going to start getting confusing a little bit. So let me find a deployment icon. So Kubernetes deployment, Netes deployment. Okay. Kubernetes. How about that? Okay. All right, let me mouse over some of these things. Okay, so this is the pod icon. Okay, so a deployment is intended for to house, most of the time it's just one pod, but maybe you might have like two very closely coupled pods. So the only thing I can think of is like, let's say you have like this fast API running out here, and you want to have something scooping out the logs of your fast API and then porting it over somewhere else. You might have a separate pod doing that, but it wouldn't make sense for that other separate pod to exist as its own thing, because its only purpose is to basically be this like helper alongside the main pod, being the fast API pod. So I'm sometimes when I do this double clicking, it doesn't really like to work. Hold on a second. I'm going to text my wife. I'm going to say, dude, live stream going loud. Okay. I love them though. Okay. So this is going to represent our fast API pod. Okay. Let's make this a little bit bigger. All right. So this is going to represent our fast API pod. Okay. And our fast API pod is going to sit inside of a deployment. I don't know which one of these is supposed to represent a deployment. Maybe none of these. I'm just mousing over these to see which one is a deployment. But okay, that's okay. We'll just call it. We'll use the same icon. Why not? Okay, so I'm gonna need to make this bigger though. Sorry. Okay. I wonder if anybody's even watching this stream right now. Let me check the analytics. No, I don't know yet. All right. So anyway, this here is our pod, and then we are going to have this being a deployment, and I'm going to represent that as a little box within the box here. So, sorry, I'm not very good I'm not used to diagramming live in front of people like this. but I'm also a super stickler, as you can tell, for like making sure that everything is lined out perfectly. In fact, I had a coworker that used to make fun of me because I used to quote count the boxes, so you could see like the little squares in between like these diagrams, and I was very meticulous about making sure that everything was very evenly spaced out. And she always used to say, "You love to count the boxes," and yeah, and that is fair. So, Michelle, if you were watching. I think about that frequently. Okay, so let me go ahead and call this blue. Let's send it backwards. This is my only. Oh wait, they added a send backwards button. Okay, it used to just be only 2 back. All right, and then so this is going to be our deployment, and then I'm gonna call this here our actual deployment, fast API deployment. Actually, I want to change the color of this to purple. Why not? Sure, because I want to make this one blue when we're done. Okay, so this represents our deployment. So within the Kubernetes cluster here, it is running. And so your question might be, okay, so let's say I'm going to make let's find a human. Okay, let's say verbal running man. Okay, I've not seen some of these. I haven't looked at these in a while. So let me just do a computer. All right, now I'm just getting nitpicky. All right, computer. Okay, so let's call this our computer. So let's say I am sitting at my computer and I want to call our fast API to get a model inference from the model that is stored within inside there. So the question is how do I basically make this guy talk to this guy? Okay, and you can't do it as a direct shot because of networking things, and so that's where Kubernetes has some other things that helped us to do this. So namely here, let's look up service. I don't know if this is going to work per se. Kubernetes service, Kubernetes. What if I just said a Kubernetes service? Kubernetes service. Okay. Darn it. I used to be really good at looking for these icons, but apparently not anymore. Okay, wow, okay, I'm going to switch out this one, API, because that clearly, well, I'm sure there's an actual Kubernetes API, but I don't like reusing icons because that gets confusing. So we'll just keep it like that. All right, so again, we have our fast API deployment running within the pod here. And then we want to be able to talk to here. So the way we do that is with 2 other resources that we can create within Kubernetes called a service and an ingress. So Kubernetes service, I'm sure it has its own icon. I don't know why I keep trying to. Let's look here. PVC. Oh, I do. We're not gonna do anything with PVCs today, but I do want to mention what those are. So PVC stands for persistent volume claim. So by default, these pods are what we call ephemeral, meaning that if we were to go and delete this pod, anything that was stored within inside that pod just goes poof, it goes away. And so you might be thinking, well, what if I want to keep that data, or even more so, like let's say I have this like shared network storage place that I want to be able to connect to all my pods. That way they can all log to the same like network storage. So that's what a persistent volume claim is designed for. So you have this persistent volume, and then you would then have the pod create a claim on that persistent volume that would then basically map that storage device, whatever it may be, up to the pod appropriately as a PVC. But we don't need to do that for our fast API. I mean, if we were doing proper logging, we would want to, but I'm not going to cover that today, especially because the particular installation that we're going to be using is it takes some extra setup to get a PVC working. Oh, actually, speaking of that, it does take a little bit to, set that up. We are going to be using something called Minikube today for actually deploying some of these things. So what Minikube is it's designed for like basically local usage for like learning purposes. It basically spins up a little Minikube cluster on your personal machine, and it can take a little while to start up. So I actually, like an hour before the stream started, I went ahead and did everything from scratch because I was so worried because I haven't done anything with Kubernetes in so long, especially on my personal machine, that I wasn't sure it was going to work. But and I got like 80% there. So yeah, in order to do that install, well, let me just show you over here. You can just do a Google Minikube. So Google Minikube, and it'll tell you, well, Minikube installation. And then if you just, well, I guess that was right. Then you can just select your parameters here, and it'll tell you how to do the proper install. So if you're on Windows, then you could do like an exe download. If you're on Mac like me, I'm going to use Homebrew. If you're not familiar with what Homebrew is basically just like a package manager that helps to install stuff on your Mac. Okay, so you could see here that the command to install that is called brew install minikube, so we can do that. And the reason I wanted to do this right now, brew install minikube, is that it took a while, and I can't remember if it took a while to start up the. Well, we'll come back. All right, jumping all over the place here. So let's go back to our diagram for now. Okay, so the service. Oh yeah, I keep forgetting that. Oh, okay, yeah, this is what it was called, SVC. Although I don't like this icon because it's not. I don't feel like it represents this thing very well, but that's okay. Okay, so this is a service, and I'll clean up this whole thing here in a little bit. All right, so this is a service, and what the service does is basically, from a networking perspective, it connects the pod to another thing called an ingress. And this is the only thing I don't like about Dryo, is if you like want to just select these things, like it, and you have something in the background, then it just wants to keep selecting that. In fact, I don't even really need this for now. I'll just bring it back here in a minute. But just note that these things are inside a Kubernetes cluster. Well, I kind of wish I wouldn't have. Never mind. Ugh, I'm all over the place, people. All right, so, well, I'm going to... I can't make up my mind. All right, so I'm going to move this up and over here. Why is this like this? All right, I'm going to make that a little bit smaller, make this a little bit smaller, bring this on up some. Oops. Bring this on up some, because I like, again, I am a stickler for even spacing on things. Okay, and well, this is the one other nice little thing about this is that then I can, it has like auto snapping aligning things. Okay, as you saw, and again, I'm a stickler for alignment. I don't like those little things like that. And this is going to be, so you can see that it's just a one-way arrow, but I'm actually going to make this a two-way arrow. In fact, I'll go ahead and bring this over here. I'm going to make this a two-way arrow, so let's make this a double-ended arrow. Sorry, there we go. All right, and then we need to connect it out to the outside world via an ingress. All right, so let's see if there is an ingress icon. So I'm going to use this, but so most people don't know this, but before the popular game Pokemon Go came out, the company behind that game, Niantic, actually came out with a game that was very similar a couple years prior. And I don't even remember how I found out about it, but I just remember thinking it was really cool. But it never caught on because it was like it didn't have the clout that like Pokemon has. But anyway, the game was called Ingress, and the logo for that game is this. And I'm like probably one of the only people on the planet that even remember that. But so yeah, this is not the official Kubernetes Ingress logo, but I'm going to use it because why not? All right, so I'm going to bring back my thing here. All right, so let's just make this. All right, and let's surround this. And I want to have this kind of straddling the edge here because, you know, that's what the ingress is designed to do. It's designed for having the outside world talk to Kubernetes appropriately. So, in fact, I'm going to have this shown. Again, I want to get this evenly sized. Well, why am I doing this? Okay, so let's do this. And then I'm going to bring this down here. I'm going to bring this forward to front. Okay, and then I'm going to do, I want to send this back, don't I? Send to back. All right, then I'm going to grab this here, here. Sorry. You get to see my OCD with making sure that the boxes are correct. Count those boxes, people. All right, so what we got? 2 big boxes and then 2 little boxes from horizontal to vertical. Okay, so I'm going to copy and paste this over. All right, so copy and paste. And then I'm going to call this our ingress. And then I want to make sure that it's got, that we can see it. I think I need to give it a fill. Okay, I think that worked. Well, let's check. All right, so I'm going to turn this blue, and oh, I don't like when it does that. I guess that's, well, actually, you know what? I'm gonna do this. How about that? Or even, well, nah, okay. Your folks are like, just like pick a lane, David. And sorry, I am just such a stickler for these little things. And I'm actually, the reason I'm being a stickler on this one is because I want to save this to the repo. That way, if people want to watch later to understand what's going on, then they can. All right, so let's do this. All right. Okay, so I'm gonna have to move these two things down, 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 and then all right. So and then we have our computer, and over there. That's 3 squares. I want 4. Well, okay, maybe that's not gonna work so well. Okay, that is good enough. All right, so I'm gonna call this our calling client. All right, so our calling client. All right, and then I'm going to call this. All right, so I know. All right, note to self: diagram things before, and then do the coding during the live streams, because I'm sure you all don't care to watch me do this. All right, so Kubernetes cluster. Oh, by the way, before I stop this, so. Over here, I think Minikube has finished installing. So in order to start the Minikube server, and I didn't look to see if there's any other prerequisites, but you might want to Google this. You may need to have Docker Desktop installed in order for this to work. But anyway, to start Minikube, we'll do a Minikube start. And I think this is the thing that takes a while. One thing I really like, I think is cool about Minikube is that they use these emoticons, which, it's the little things that count, people. Okay, so let's go ahead and make this bigger, text bigger, and let's shrink down this box because we don't need it to be that big. And then I'm going to put the cluster, well, I wanted to put it here, but it's kind of big. Okay, we're getting close. Oh, by the way, I didn't even realize when I scheduled the stream that this week was KubeCon. So KubeCon, of course, we got a lot of different cons these days. KubeCon is the Kubernetes convention. I personally didn't attend anything this week just because I was super busy with regular work. But I thought it was just a fun coincidence that I just happened to see later. Okay, so I'm going to move all this up here. And this is my final diagram. There you go. So draw.io, you can build stuff out pretty quickly. Well, I'm almost there. I want to center that a little bit better. Is that good enough? Good enough. All right, so again, the way this works. So the calling client, if they want to get an inference from the fast API, which is in here, they are going to go through the ingress, and the ingress is going to talk to the service, and then the service here will route that call on down into our pod, and then it'll generate the inference, and then back up the chain. So back up through the service, back up to the ingress, and then our client gets their the thing that they're wanting. Okay, so I want to actually go ahead and save this because I do want to, like I said, I do want to use this later. So I'm going to call it, oh, by the way, so Kubernetes is often abbreviated as K8s because Kubernetes is an 8-character word. Fun fact, in case you didn't know this, another popular shortening like that is A11Y. A, and then the number 11, and then Y. And what that is for is a shortening for the word accessibility. And the reason for that is because Twitter is, well, at least back in the day, it used to be a lot shorter of the character count, so people would abbreviate these things. And so that's how Kubernetes got shortened to K8. So I'm going to call this K8's architecture, and I'm going to save it to my device. Well, by default, it just saves to your downloads. And then I'm going to export this. Export as PNG to, and for some reason, sometimes you got to save it as 400% zoom. I don't know why, because it just, if you save it as 100% zoom, it sometimes comes out really tiny. Do I want a border? No, I don't need any border. Okay. And then I'm going to take this little thing off, and then that should be good. All right, so let me go into my downloads here. Where's my doc? Hello, doc. All right, I'll just go to downloads. and then it should be in here. Okay, yep, there it is. Apparently I saved this twice. Okay, because basically this file here is just an XML file, and it's just got like a bunch of gobbledygook, basically, or some stuff that like a human can't read. Okay, so there is our conk line, and this is what I was talking about. So you see this pixelation? Ugh, this bugs me to no end. Okay, I'll fix this later. Okay, so let's actually start to code this up. Let us go into here. Okay, so I mentioned before that I was building my Docker container, and just to show you that it is working, so let's do a Docker run, port 8080. Let me move my face out of the way again, top right. All right, so why is that? Oh, that I know why it's not running. It's because it's already running. So that's one thing you do have to be careful with Docker, is that if you start something in your Docker local, it could happen that you accidentally forget to run. So this is actually still running, I believe. So if I do a Docker PS, I don't remember what PS stands for. So you can see here, yeah, it's already running. Okay, so let's go ahead and delete this. Okay, so it looks like Minikube actually is a Dockerized installation. So maybe you do need to have Docker install on this. So I'm going to do a Docker kill. All right. Okay, so let's try this again. Docker, gotta go. Oh, wait, no, that's fine. Docker run. Okay, so what this is, again, what this command is doing. Oh, that's why. It's because I changed this. It's not SageMaker anymore, it's just BYOC. Okay, so when we do the Docker run command here, the P flag notes the port mounting. So as you might recall, Docker desktop doesn't expose those ports necessarily by default to your local computer, so you expose them this way. So we're exposing 8080 on 8080 just to keep things simple. And then we're running our serve script, because our serve script in here, as you can see up here, is using Uvicorn to start the fast API instance. All right, so let me go ahead and run that, and hopefully this time it'll give us the messaging that I'm looking for. But I also did some tweaking, so now I'm wondering if something's not running. Okay, it looks like it's running now. Okay, so let me just go ahead and do a split right, just to show you that it is indeed working. So cd test curl scripts, and then so the curl script that we're going to be running is this one here, local predict. And so again, it's running, the pod's running at localhost 8080, and we want to hit the invocations endpoint. So let's go ahead and so basically when we run this bash local predict, we should get the proper inference back. There we go. So you can see here, survival prediction is 0 for, I don't remember what this test JSON has. Let's look. Yeah. So as you might recall from previous streams, that one of the strongest feature indicators for this data set is whether the person was male or female. If you were female, your chances of survivability were much higher than males. So yeah, seeing that this person did not survive is not surprising at all to me, or at least this is the inferred result. I don't know what the actual result is. I'm sure it's in my test data or another data set somewhere. But anyway, so this is working. So let us go ahead and let's go back to Minikube here. So we are starting to install it. So the way we interact with Kubernetes in general is using this command line tool called kubectl or kubectl. I don't know how people typically pronounce it. I've heard it pronounced a billion times, but you can even see it right here, kubectl. Let me move my face down again. So let me just show you a couple of commands with kubectl. Or well, of course you can always just do the help, so it'll tell you all the different commands it can do. So just to show you that I am running in Minikube right now. Excuse me, I'm going to do a kubeconfig current context, and that will show my current context, which is Minikube. Sorry. But yeah, so you can see Minikube is up and running. I think this is the part that takes a long time. All right, so one thing that we do need to do that Minikube by default just doesn't have enabled is we have to enable the ingress controller. So Minikube add-on. Okay, yeah, add-ons enable ingress. And by the way, I am writing another README under this KH directory here of this repo that you could see here. I need to add more to it, but I am going to put all these little gotchas in here. So I'm making notes for myself, and I'll come back and populate this all later. All right, so the ingress add-on is added. Let me just check my notes here to see what else we need to do. Oh, so by default, whenever you do a Docker build, it actually stores all your images in a local Docker registry. Whereas with Kubernetes, if or at least with Minikube, I should say, It by default can't get to this Docker registry, but it can be enabled to like get there with a little command. So all we have to do here is run eval minikube docker env, and then we have to rebuild our image again, and it'll rebuild as part of that minikube Docker registry, if you will. So let me go in here, and then I hope this will build really quick because I did this like an hour ago before the stream started. I need to take a sip of water. I'm doing a lot of talking, a lot of content to cover, but I hope this. I'm kind of happy with how things are going. Aside from the fact that like you guys probably didn't like watching me do my diagramming. I feel like this stream has been a little more organized today. Okay, so CD Titanic, BYOC. What was I doing? I have no idea what I was even supposed to be doing right now. The ingress is on. Okay. Oh, we need to do another Docker build. Docker build Titanic BYOC, and hopefully it should just. Okay, yeah, it's just doing caching. I don't know why. Yeah, I don't know why it didn't cache this part, but that's okay. So this might take another 5 minutes to run. But basically what this is doing is building the image again for use on this minikube platform. You don't have to do that with with like a standard like legit Kubernetes cluster. You do have to do that with minikube. Like I said, a couple little gotchas with minikube, but and one thing to note, and I may have said this already, minikube is not designed for production usage, so do not use minikube for production usage. If you do want to use a Kubernetes cluster and you don't necessarily want to buy all the hardware to do one, both AWS, Amazon Web Services, and Google Cloud Platform both offer their own versions of Kubernetes clusters. Honestly, I've never used Amazon's version. So Amazon's version is called EKS, Elastic Kubernetes Cluster, or Elastic Kubernetes Service. Sorry. I've heard that it's pretty decent for the most part, but I've heard it's got its quirks. Now, keep in mind, as I mentioned before, that Kubernetes is a Google product, and so they actually feature the Kubernetes engine over there much more prominently than I think than what AWS does. And in fact, so I am a Google Cloud practitioner or a Google Cloud Platform Associate Cloud Engineer certified, and part of that certification, a lot of that was just covering the Kubernetes engine. But I got that certification, almost 18 months ago now? No, it's been almost 2 years ago now, so there's a lot I've forgotten. I do want to get back, so I don't work in Google Cloud Platform hardly at all. Like, I don't work with it on a day-to-day basis at work, so I've forgotten most of that. So I do want to get back to eventually using that, or eventually doing a deployment to Google Cloud Platform with one of these streams here. So what was I mentioning with that? Oh, okay. So yeah, if you want a production ready implementation of Kubernetes, use Google Cloud Platforms and their Kubernetes engine, or use AWS and their Elastic Container, or I'm sorry, not Elastic Container Registry. That's another service though on AWS. Elastic Kubernetes Service. Sorry. Yeah, so many little acronyms on AWS. It can be hard to remember sometimes. Okay, so you can recall that this is going to take a while, but that's okay. We can actually go ahead and start writing what we... Okay, I was starting to show kubectl, so let me go... Uh-oh, what did I do there? No! I don't know what Command R does. Didn't mean to do that. Okay, so kubectl. So I showed the config current context. So there you go. Other popular commands. kubectl get... get is a very popular command just to show like all the things that are running as part of your Kubernetes cluster, but you have to define like the class of stuff that is running. So like get pods. So it should show no pods. Yeah. Get kubectl, get deployments, should show nothing. kubectl, get services, should show nothing. Okay, well there's that one there. And then kubectl get ingress I don't know what it shows anything. Okay, so you don't see anything now, but as we start to deploy stuff out into Kubernetes, you will see different things populated here. So the way there are a couple different ways that you can deploy things out onto Kubernetes, and I'm not even going to bother with like the one path that in my mind, there is only one right way to do it, and that is using YAML files. So YAML files are, what does YAML stand for? Yet another Markdown language. So kind of tongue-in-cheek joke there. But basically, like, you use these YAML files to actually define like your deployment, and you define your ingress, and you define these other things. So YAML files, it can be pretty granular, or they can be like more like, so what I'm trying to say is, so those three things. So coming back to our diagram, where's our diagram? So that we're going to be deploying 3 different resources onto our Kubernetes cluster. The deployment with the pod, I count that as 1, and then service number 2, and the ingress number 3. So we could have 3 different YAML files for these, or we could shove them all into one. There is not a right or wrong way to do it. You just have to. It just depends on how you want to do it. I'm going to actually just keep it all as one. So over here under our K8s directory, I'm going to start a new file called API deployment.yaml. And I don't know if it matters if it's YML or YAML. I don't think it matters. So let's go ahead and start writing this. So I'm going to, you can annotate with comments again, just with the pound sign or hashtag sign, whatever you want to call it. So I'm going to be defining the API, or the deployment /pod for the Titanic API. And so the way this works is that there's some APIs that Kubernetes has under the hood that basically kubectl can talk with and say, okay, I want to talk with this particular API and give it all this information to build my specific pod. So I'm going to say API version v1. Again, these are things that you don't need to memorize, and I actually don't have these memorized. The only reason I remember is because I just did this an hour ago, just as like a refresher. And in fact, you might be wondering, what is this file over here that says shh.yaml? This is the, well, let me go ahead and show it. This is the actual thing that we're going to be writing. I wrote it beforehand just to make sure that I remembered everything, and I'm glad I did, because there are a couple things that have changed ever since that I've used it, and I have to go back and reference this because, you know, like I like to say, it's more important to understand this concept here of like this architecture, this whole picture, but the actual syntax of trying to learn everything, we're not going to beat ourselves up over, because we've got our friend Google to help us out with that. All right, and so I know it's API version, and I think its kind is deployment, and then I'm already going to have to start referencing this other file because I really don't remember like some of these things. So kind deployment, metadata, we're going to call this, I think is there labels? No, okay. Name, Titanic API, okay. What is it? Is it spec next? I think spec might be next. Again, I'm just going to have to keep toggling back and forth because I really don't remember. Okay, so I mentioned before that we'll just do one replica. I might alter this and show you like, oh, well, actually, let's just start with one replica, and we'll show you how 2 replicas works later. So replica, and then I think so the one thing that's always been super confusing about deployments to me is that like you have to do something called a selector, which basically tells the deployment, okay, I want you to tie yourself to the pod that we're going to be defining here. Well, let me go ahead and write it out, and I'll show you why it just doesn't make sense to me. So I am not Kubernetes certified in anything. This is the one platform that I work with that I'm not certified in, like in the CCAT or anything like that. All right, so selector, match labels. Okay. All right, so selector, match labels. Also, the indentation is important with Kubernetes, and that's the one thing about these YAML files, is that the YAML files can be really annoying to try to remember some of these things. Okay, so I'm going to call this app Titanic API. I don't know if it matters that this is called app because I've seen it defined elsewhere otherwise, but just note that whenever you'll see why this, we'll have to pattern match the syntax later on. So let's come down here. I think template is next. Template, and then I think spec again. I'm gonna have to go back and look just to make sure I'm not forgetting anything. Okay, template metadata. Okay, template metadata labels, Titanic API, just keeping things simple. Titanic API, and then I think next is spec. I'm gonna have to go back and remind myself really quick again. Okay, containers. Okay, containers All right, so we're going to, all right, our first one is going to be called, well, our only one, I should say. But this is where, so if you did want to do multiples, then you could just define another name of the things here. So I'm going to call this again Titanic API. Okay, so this is the part where we start defining the image and stuff. So our image here is going to be the one that we built. So Titanic API dev. And then we need an image pull policy. All right, so here's one. I'm glad I'm remembering this, so I'm making a note for myself later. Image pull policy. Okay, for some reason, this is another little Minikube gotcha. Most times, so what this is basically doing is saying, you know, if this container were to stop for any reason, so this is another nice thing about Kubernetes. Let's say your cluster goes down for any reason, and so obviously all your pods and stuff go down too. When your cluster comes back to life, it will have all these YAML files saved, and it will know to like how to properly rebuild everything. And so that's what this image pull policy is saying is like, okay, do I need to pull this image again from wherever it's sourcing it from? So in almost every scenario, you'll just want to say always. But for Minikube specifically, I have to go back and look. There is a gotcha here. The Minikube gotcha is if not present. Again, that is just a little Minikube gotcha. Not something that we need to necessarily concern ourselves with for other things. So, or the other platforms. So, we can do a lot more things with the defining here. So we can define environment variables. We can define those persistent volume claims and how they get mounted up into this pod. The only other thing that I think two other things. So I know we need to initiate the command. So as you might recall, when we did our Docker run, I didn't even stop this. Whoops, didn't mean to do that. All right, I'm gonna stop this. Ugh. Okay, terminate. All right, I'm gonna do Docker PS. Docker PS. I'm gonna kill this container. Docker kill. Sorry. All right, and so just recall that when we did the Docker run, well, I guess I could have shown this just in the Docker file here. The Docker file, if you might recall from last time, we could have set something here at the end called a command. So what this command is basically doing, and the syntax works like this, is when the container starts up, it is going to look by default for this command, and that is serve. So the serve maps up to this little file here, which, as you might recall, is our actual starting of the API. There are reasons that you don't want. There are reasons that you may or may not want to have like a default command. We actually don't, because the way that SageMaker works in specifically is if you want to use the same container for model training versus model serving, then it has to initiate the command like based off of the server, the train script. And so that's where when we did our Docker run down here, and I'm not going to run this command again. Docker run, you can see that it has the command, the serve command here on the end. And therefore, basically, so the question is if I don't include serve here, then how on Kubernetes do I initiate that command? And that is simply done with this command here, or this parameter here called command. And again, same thing here. So I'm going to call this serve. And if I wanted to pass in arguments, it actually is a separate thing called args. And just keep in mind, if you did want to do arguments, they have to be all like its own like little thing here. So hello, I don't know. I don't need to pass in any arguments, but just keep a note that like you can't just pass it all as one big string. Okay, so command, and then I think the last one is port, but I can't remember how to expose the port necessarily. Ports. Oh, I forgot about resources as well. Okay, so ports. Ports. Oh my gosh, I'm already forgetting. Name, HTTP. All right, so why do you do this to me? Name, oh my gosh. I know it seems like, okay, I'm not actually being a stickler here. Like this is actually like a Kubernetes gotcha. Like if you don't have the stuff properly like aligned like this, then it just kind of just doesn't work. So, but I can understand why you would think that it's just me being a stickler again. All right, so name, what was it? It was a port number. I gotta look at this again. Port number is, or container port is 8080, and the protocol is TCP. Container port is 8080, protocol is TCP, And then the last thing that we need to find, so this is what I was talking about earlier, where the nice thing about Kubernetes is that you could share resources like CPUs and stuff, and you could even use just fractions of a CPU. So I'm going to put resources, what was it, request, or no, is it CPU? Sorry, I gotta look again. Okay, so I'm doing request CPU 500M. I don't know what the 500M stands for. Request CPU 500M. Okay, so in case you're curious, why do we have to note this thing as request? Is because Kubernetes does have this feature where you could have request versus limits. So basically saying like, okay, request is this idea of when the pod starts, this is how much I want it to start with. But let's say like, I need more compute power for a more intensive task, what am I trying to say here? So you have peak times, of course, like during like a regular business day. So you may want to have flexibility where your pod has access to more resources if it needs to for compute reasons. And so you also may want to make sure that like, hey, don't go too crazy. So that's where you define some limits here. So limits, and then we could do like CPU of 1,000. So again, I don't know what M stands for here. I think you could just do full integers, but I don't want to do that because I just want to use the fractions. And in fact, I'm not even going to worry about limits. And CPU is not the only one you can do a request or limits on. You can also do RAM. I don't know if it's called RAM necessarily. I think it's just called memory. Okay, so, but anyway, this is the full deployment, I think. Let me do one quick check to make sure that this is everything. Okay, yep, that's it. All right, so in order... again, like I said, if we wanted to separate the service versus the pod versus the API, then hold on, I'm a little. I think I'm missing something in here. I feel like I did miss the selector image labels app metadata app. Did I do the selector image labels app? All right, metadata. I did something wrong in here. Yeah, for sure. Labels. Okay, I knew something looked wrong in here. Okay, app, Titanic API. Okay, so this is what I was talking about. Is what the selector here is doing is saying, okay, I want to build, or I want to get the template based off of like the things here. And so I want to match the label of Titanic API to this one. So that's the thing I don't understand is like, why do I need this here? Like is not the deployment smart enough to know, okay, if I'm defining a template, then clearly that's the one I want to use. And maybe I'm being ignorant about something. But in my mind, you should just not have to include this, but you do. And because if you don't include it, then basically you're creating a template with nothing inside of it. So, or a deployment with nothing inside of it. It doesn't make sense to me. I'm sure there probably is a reason for that, but anyway, that's just another little Kubernetes gotcha. Okay, so if I wanted to keep everything in the same file, the only thing that I have to do is whenever I want to start a new resource, I just have to put 3 dashes like this, and then I can start doing another resource. All right, so here we're going to define the service, defining the service that connects the fast API, or what was called the Titanic deployment / pod to the ingress. Okay, so the way we do that, again, API version, I don't know if this is v1 or not, because that's another thing is it can be a little confusing. Okay, so it is v1 kind of service. Okay, and we're gonna see some networking terms in here that honestly I don't know what they mean. Just being transparent, but they are important to keep in here. Kind service, not services. Okay, I gotta go back and look in here again. Okay, okay, so metadata. Ooh, I'm starting to get a little bit of a headache and a little bit of nauseous. I don't know if you can all could tell that. So that's making me a little bit sluggish. All right, so metadata, what is it, labels? I don't know if that's right. Metadata name, okay. Sorry, it's so hard to remember these syntax things. I'm sure that if I worked in Kubernetes on a very regular basis, I would remember this. And actually I did used to. The company that I work for, they do still use Kubernetes, but we've been moving more toward AWS, and therefore like I've spent a lot more time on AWS recently. All right, so I'm gonna call this Titanic API service. All right, and then I think it had like a subtype of something called like node port, but I don't remember what the node port was. Let's look. All right, so, okay, spec type node port. All right, so spec type node port. All right, I'm gonna have to go back and look in here again. All right, so ports, target port. All right, ports. All right, ports. Oh man, I'm already forgetting. Port, target port. All right, so port 8080. Again, we don't care to change up the ports on us. Target port 8080. And then I think the protocol was the protocol's TCP again. Protocol TCP. I might be misremembering that. Okay, no, that's right. And then name is HTTP. Name HTTP. And I don't think these necessarily need to be in this precise order, but you know, if you just to keep things simple for you, I wouldn't go trying and messing with the order per se, because I know this order does work. All right, so name HTTPs. All right, so selector. All right, so selector app Titanic API. Okay, so what this is basically doing here is saying, okay, I want to have this service connect on port 8080 of selector app container or Titanic API. So as you might remember, coming up to here, looking at the metadata, this is why metadata is important. We've defined this thing here as app Titanic API. Therefore, we want to connect to the Titanic app API. So this is where deployments are really nice. So like, let's say I wanted to have multiple replicas, so 2 replicas, but I didn't want to have to create a service that connects to all those individual replicas. What this is basically doing with the unified deployment is you are connecting this service up to the deployment, and then the deployment does the load balancing for you behind the scenes. So like, let's say you have 6 replicas, you only have one service connecting to the deployment, and then the deployment is just filtering down to the 6 replicas appropriately. So that's really, really, really nice. And we might demonstrate that here in a little while. Okay, so I think that ends the service. And of course, the last thing is the ingress. Defining the ingress from the Titanic pod / service to the outside world. Okay, so again, just as a quick refresher from our diagram here, what we're basically saying is, okay, we want to define this guy that connects our calling client into our service. So there is one thing here that I want to note that, again, I've noted a couple gotchas with Minikube specifically. There is a way to enable like a proper ingress with Kubernetes or Minikube locally. I could not get that working, and I don't think I'm going to be able to get that working today. But there is a way to kind of bypass this to go from the client to the service. It's not recommended that you do that, and the reason is, well, you'll see here in a minute. Okay, so API version. So I'm glad I did this stream before because before this was still in beta, so the API version used to be like v1 beta 1, and it's changed, and thus the syntax has changed as well. And so, in fact, I'm not even going to, just to save some time, I'm just going to copy paste this. So I hope you all aren't mad at me about that. Because how far? We're already an hour in. I forgot, 3 o'clock every day, my little fountain back there shuts off. But I don't want it to shut off now. There we go. Back on. Boop. Okay, so let's talk about what's going on here, or at least to the best that I can understand. So again, we're defining our metadata here with the name of Titanic API ingress. I don't know. Again, I'm not a networking expert or a Kubernetes expert. I don't necessarily know what this annotations thing is doing, but I know it is required for us to get our stuff working. And then, so what we could see down here is when we define our spec is, theoretically speaking, we should be able to just do like a curl call against this Titanic API local URL, and then everything should work. Because what it's basically doing is saying, okay, I want to path, like at the base level root of this prefix, I want to connect down to this Titanic API service 8080. So what I should be able to do theoretically is curl Titanic-API local /ping, and that ping being our health endpoint, if you recall. Let me just show you all that again. As a reminder, so you can see ping and then it will return the response. But for some reason I can't get it working, and but that's okay because I found an alternative way of working around it. And after this stream, I will, not today necessarily, but I will figure out what the deal is there, and I'll make the note of that in my notes here. So yeah, okay. So this is our basic YAML file, and I don't need anymore. All right, so delete. I don't know if anybody knows the reference I just said there with delete. I'm a big fan of the movie Scott Pilgrim versus the World. And when Michael Cera gets his first email from one of the first exes that he has to face, he just brushes it off and just deletes it and says delete. And that was my super subtle Scott Pilgrim versus the World reference. Okay, so now how do we actually deploy this out onto Kubernetes? So what we do here is, let's go into the actual repo. Well, I think I do have it open here. All right, ls. All right, so let's go down into our K8s directory. So you can see we have our API deployment YAML there. So the command for this is kubectl apply f. F stands for like find, basically, like, and so we're gonna find like this YAML here. So actually, you don't need to do the F. I think you, if you want to apply everything in the directory, like let's say I had multiple of these YAML files, I think it's just I think it's just F period. Let's see if this worked. Unable to recognize for kind deployment, unknown field names. Oh my gosh, I wish I wouldn't have deleted that one thing that I just deleted. Can I do a Z? Oh no. All right, I'm gonna have to dig into my recycling bin here real quick. Hold on, folks, because I apparently got the syntax wrong on something. Can I put this back? Where are you at? File, where are you? Oh no, oh no, I can't find it. Okay, let's figure out what I did wrong here. Okay, so I actually have a different project because I've done this before. Okay, so let's open recent. DS quick tips. I know I did this as part of another effort. Oh, so by the way, I recently updated what do you call it here, IntelliJ, and now it has support for like, you know, because the one thing we have the tabs for our individual like files within a project, but now it has project level tabs, and I don't know how long that's been around. So like you could see, boof, we can toggle back and forth. So this is what I was looking at earlier, because this is what I did for another MLflow project, which by the way, I do want to do something on MLflow. Okay, so this might be the issue here. Apps v1, and then I think in here was apps v1 again. No, it was just v1 there. See, that's the one thing that's a little bit confusing, is the API version here. But again, don't try to memorize things. Just try to remember the concepts. That way, because you can always Google later what the issue is. All right, so validation error. So that's one nice thing about this is unknown field names. What names field is it talking about? Names. Oh, I wonder if it's that metadata thing there. No. I'm going to have to do Control F. What is names? Oh, well, okay. That might be it right there. All right, let's try this again. And in fact, I'm going to move this over, rearrange our windows. All right, so let's do an apply F again. Let's see. Okay, so what you can see here is that it went ahead and created the things. So now let's do a clear. So let's do a kubectl get deployment. So what we should see is our deployment starting. So you can see that it has our deployment with one pod. 0 out of 1 is ready because it might take us a few seconds. So let's go ahead and do this again. So far it's not ready, so let's check the actual pod. So kubectl get pods. Image pull back off. What's going on here? Oh, duh. Oh, wait. No? Okay, so anyway, I screwed something up here. So in order to delete everything, is kubectl delete F, and then that file. So it's going to delete everything. I think that it was that I just didn't set this properly, or maybe, I don't know. I thought I did, but maybe not. Kubectl, well, I can't do a delete if it's not there. Let's do an apply again. IF apps API. Okay, so kubectl get pods again. Okay, is it gonna pull back off? Ugh. I'm gonna go nuts with this. Okay. I really wish I would not have deleted the other file, because I know the other file worked. But it might be that I just tore down this whole Minikube cluster before like I started it, and then I tried rebuilding it on the fly, and apparently that was not a good idea. But I wanted to keep things fresh for you all, because, you know, it's not really fair to you all if I'm already, like, you know, all the way down at this end of the spectrum, and then you're just starting off here, and then you're trying to debug all the errors. So you might be encountering the exact same error if you're trying to follow along with me right now. Okay, so let me try to figure out what is going on here. So let's do another delete. kubectl delete f. Okay, deleted, clear. I'm gonna try again. Let's. All right. Trash. What is trash shell done? Oh, I don't know what that is. Okay, so let me pull up my Finder window. Trash. This Mac. Trash. I didn't realize that if you do a delete within IntelliJ like that, that it just deletes it right out. But I don't think that would be the issue. But I think what the issue is that I just need to do another Docker build. Okay, so let's make sure eval. Oh, I know what it is. It's because I accidentally hit that weird Command R thing and it didn't finish building the image. All right, that's kind of annoying because this thing takes forever to build. Oh wait, I need to go up one directory. Docker build. All right, so that's why I can't find it. Oh, okay. Thankfully, it cached everything. Oh, good. Thank goodness. All right, so let's go down into K8s again. Let's clear. Let's do an apply. kubectl apply f. All right, so there we go. Pods. All right. Why is it having an issue now? Okay. kubectl describe pod. Not reachable. May not exist. Titanic API. Did I not type that right? Titanic API. Oh, yeah. Duh. Oh my gosh. How foolish of me. All right, so this is supposed to be BYOC. So these, okay, I guess this isn't a bad thing though, because if you're not used to the development world, this is exactly the kind of mistake that developers make all the time. It's silly little things like that. And so somebody was asking me the other day at work, what are my thoughts on pair programming? And pair programming, I think, is best for when you are stuck on something and you have no idea why. Because sometimes you just need a second set of eyes that, like, I can think of me and another coworker were working together a couple months ago, and I spent like 24 hours trying to debug this one little thing. And I brought him into a call for pair programming, and boom, he saw right away that I had spelled something wrong. So again, the spelling on these things counts. So that would be why it can't find this. So let's do a kubectl delete. All right, so all right, clear kubectl apply f. And now let's hope it works. Yes. Okay. Now, just to prove that it is working. So one thing that we can do is we can grab this pod and we can do basically SSH into it. And kubectl calls that what do you call it? An exec command. So it's kubectl exec IT. We need to have that IT flag because that is basically saying, okay, whenever I want to SSH into this, I want it to pipe all the commands into my local command line here. You like my hand waving? Okay, so here's my the name of my pod, and I think you actually, the syntax has changed a little bit. I think you have to do a dash dash, and then we're just going to bash into it. Okay, so you can see here, I am inside of this pod, and you can see that we have started up in the opt program directory, just like we want to do. So if I do an ls, you can see all the files in here. If I were to do a cat on serve, then you can see that we are starting these. So these are the same files that we started up over in here. So great. So we can see that it is running properly. All right. So all right. This one other thing. Again, we didn't mount any persistent volume claims to this, but persistent volume claims would show up just as any other directory. So usually I mount like a persistent volume up to the opt directory as something else. It would just show up as another directory. It wouldn't like be anything fancy if I like execing into here. All right, so let's go ahead and exit. So let's look at the services. So kubectl get services. Okay, so you can see here that we have our API service, and it's being served on this 8080 port as part, and then being served out here. And then finally, let's look at the ingress. Kubectl get ingress. Okay, and so what this is basically saying is, okay, in a perfect world, I'm just being upfront right now. I already said this is not working, and I don't know why it's not working. I should just be able to call the Titanic API.local with the curl command, and it should work just fine. And so, by the way, some of you networking people might be like, well, did you add it to your Etsy host? Yes, I did. It's still not working, but I'll figure that out later. But there is kind of a way around it that Minikube does offer. So what it does offer is that you can expose your service through like a special command here. And so that's what we're going to do just to demonstrate that, yes, we can connect to this pod. So Minikube, I think the command is Minikube service. And then you have the name of your service. And so when we hit enter here, what it's going to do is basically start up this little thing that allows us to directly interact with our Kubernetes or our pod here. So it is being started up behind here. So you can see that there's nothing found here because this is the default path, and of course there is nothing found. But if I were to just add a ping on here, then you can see, boom, status healthy, which is, again, exactly what we wanted to see. So let's say I actually wanted to do a curl against this. What is this called? All right, so I need to grab this, and I'm going to bring it down into, as you can see here, I have a little bash script, so I'm going to replace this here. Place this here with invocations. All right, so now, all right, so if I were to go into, oops, I didn't want to do that, cd Titanic BYOC, ls cd tests, cd curl scripts. I'm so meticulously organized about my directories, but it can be a little bit annoying at times, I'm sure. Okay, I want to, well, yeah, okay, this should be fine. I'm going to make this bigger because my icon was covering it there, I noticed. All right, so if I were to do just a bash minikube predict, which is basically executing this thing, boom. Look at that. Hot dog. All right, so what this is basically doing is doing the proper curl request and sending in our JSON and getting back the response properly. And so actually, I wish I would have done this. Another thing that I like to use, so this right now, by the way, is running actively. If I were to, I can't run any other commands because this is like its own little thing that it stood up. So I'm going to go into a different tab here. So I'm going to go get the name of the pod again. So kubectl get pods. All right, so name of the pod. If I wanted to look at the logs of the pod, I do a kubectl logs. And then I usually like to add the follow flag because the follow flag keeps it alive, I think, for 4 hours. Then you can see that, okay, yeah, so this is perfect. So whenever I just tried to do like the baseline path, you could see a 404 not found, of course, because there is nothing at the base prefix. And you could see when I wanted to do a get on ping, that'll work fine. Now, let me go ahead and do another new window. Because I just want you to see that whenever we do the curl again using the same little script, that it actually does work. So let me get into my repos, cd Titanic test curl. All right, so then let's do the bash. All right, so watch the screen on the window on the left. All right, so when we run this, boom. All right, so we got our score back here. You can't tell I'm pointing at my screen up here. Whatever. So you could see that we got our prediction back, and then you could see off on the left there in that left window that it did say, okay, we got another post from the invocations, and so everything is all good. Great. All right, and that is really how Kubernetes works, or at least that's how we got everything working. Again, so we shouldn't have to do this like weird kludgy business to like expose the service in order to do the curl. It should work that the ingress does its thing. I will go and figure out what the issue is, and I will write it up in the README here to figure out what's going on there. But we've been going what? Oh wow, it's almost an hour and 20 minutes in. So I think we're gonna call it a day. So I'm gonna go ahead and close this out. I don't know if it necessarily matters that you keep your Minikube cluster up or not. But if you want to take it down, and I'll go ahead and take it. Well, actually, I'm going to do a delete. So kubectl delete. So all those things are gone. And I'm going to do a Minikube stop. So Minikube stop. That's going to Minikube. All right, Minikube stop. All right, that's going to stop all these things. So it's now powering down and everything. And again, if you want to just bring it back to life, you just do the Minikube start again, and it should be all good to go. Again, I don't know. I'm personally just stopping it because I don't know if it's going to affect any of my other things, and I don't want it to. But just keep in mind it does take like a couple. The stopping doesn't take so long, but I think it takes like a solid 5 minutes to start. But all right, let me just do a quick review here to make sure that I didn't miss anything. So I'm going to go ahead and commit these things. just so you'll have them for now, but just note that I do need to update the README. So adding initial K8 files. Okay, so I'm going to go ahead and commit and push those. Okay. All right, let me go into Safari here. And then I just want to show you, well, actually, so if you go to dkhunley.com, it just goes to a link tree. If you want to find this repo, you just go into GitHub here, and you can see that it is the under here, Titanic BYOC. So this is the same project that I just pushed up to, so you can see that I just, I'm a little, hold on, did it not push up? Oh, yeah, duh. No, it didn't. Okay. All right, here we go. I'm not crazy. All right, so there we go. Let's do a quick refresh on this. So we should, okay, so see 37 seconds ago, we got our new K8 file. So if you want to follow along with the exact same deployment file here, there you go. There it is, the whole thing in its full glory. And again, just as a reminder, you can separate these out into its own logical groups. And if you want to keep them all in one, just note that you have to separate them with the 3 dashes like so. And that is all for today. So, folks, I hope you enjoyed this. I'm not sure what we're going to do next with Titanic. We might start to go back into SageMaker with, you know, because I'm tempted, because we already have our container working and our model trained. I do want eventually want to do a stream where we actually train the model in SageMaker instead of doing it locally. But I'm tempted to just, for the next one, to just actually just take our container as it's working right now with our already trained model and deploying it out as a SageMaker endpoint. That might have to be a multi-stream thing, because what I basically want to do is, yeah, it is going to be a multi-stream thing, because we want to actually deploy it out via the user interface of the AWS console, but then I eventually want to do everything in Terraform, because Terraform is a lot easier, or not a lot easier, but it makes it a lot easier to tear up or bring up and tear down resources. So, or we may actually hop back to our movie ratings model, because I haven't given that one much love in a little bit. But I wanted to come back to Titanic because it had been a while since I've done anything with Titanic. And hot dog, what a perfect timing that we did a Kubernetes stream right at the end of KubeCon here. So if any Kubernetes people are out there watching this and tearing their hair out because I butchered the description of Kubernetes, sorry. But at least we got things working. So I'm not a total dunce when it comes to Kubernetes. But I'm going to go ahead and wrap up today. Thank you all for joining. We will catch you in the next stream. So hope you all have a good day. Hope you all have a good weekend. I keep looking down here because I'm trying to end this properly. And goodbye.